Hello everyone, my name is Hyun from Sangmyeon University. It's my great pleasure to present our research result to you. The subject of my presentation is R-QAML MAC protocol for energy saving and support collective service in wireless sensor network. The purpose of our paper is support the priority data in wireless sensor network. From now on, I'm going to talk about the R-QAML MAC protocol. The contents of our presentation are follows. First, introduction of my paper is mentioned, followed by related works. In this part, I'll mention some of the problems to be solved, and then I'll explain how R-QAML MAC works. I'll explain R-QAML MAC's QA support method and operation method. I'll also explain how energy saving works. After that, I'm going to go over performance evaluation. Finally, I'm going to explain the result of the thesis. The application wireless sensor network is increasing, and the fields can be roughly classified as follows. Environment, detecting noise and air pollution, water pollution level measurement, and natural disaster management field, and agricultural fisheries sector, vegetarian management of farm animals, wastewater concentration management, water quality and water temperature management in fish farms, and medical fields is important field, hospital patient management, remote medical support field using home network, logistic distribution is inventory management, transportation field is toll collection and telemetric fields, and other many fields and using the wireless sensor network. Sensor nodes collect a wide range of data in different environments. The collected data may be classified into two. One is an event-driven data with higher transmission priority, and the other one is normal data, regular measured data with lower transmission priority. As you can see from the figure, event-driven data and normal data are mixed and delivered the sync node. Since normal data and event-driven data are mixed and retransmitted, there is a problem in that it's not possible to differentiate the service according to the emergence priority of the data. And event-driven data and normal data and mixed, transmit and retransmit. In other words, there is a need for a method of separating event-driven data from normal data and transferring them to sync node in the emergency order. Related research EQ-MAC protocol operation is follows. EQ-MAC is two of temporal Q and Q, FIFO-Q. Received data packet are first classified and then buffer allocation according to the priority of data and channel access and carry out. Packets are classified temporal Q and FIFO-Q. The decision of the transmission node is contention based, but data transmission methods adapts the TDMA mechanism. EQMAC is basically classified 2Q but it's only applicable to one hop structure between sensor node and head node. So it's difficult to apply wire sensor network. This is because wire sensor network has a multi-hop structure. And then next related work is QMAC. QMAC has multiple Q to support priority data classified and stored and multi-Q. Classified data by application contents and different priorities are applied according to the number of traversed hops provided in MAC layer. But it cannot reflect various network change because it does not consider the surrounding environment of the packet. And related works and important things, reinforcement learning. Rewards for node destination is variable, and next this way has the different value. Reward display for each node transmission destination. The rewards value is all different depending on the direction. The following expression is a value for priority classification. If the current state SK select action alpha in the policy phi, the next station becomes SK plus 1 and the expected compensation value is expressed as E phi. The following equation is a function that determines the reward value in the state, and it can be seen that both the rewards in the current state and the pi are affected. Priority is determined according to the value obtained through the equation. The following equation is an equation for Q value to determine the transmission priority. Transmission probability has calculated and expressed Q. Transmission probability P, and it can be seen the state, rewards, and action all determine the Q value R S, A means reward value when action alpha is taken and state S. When the transmission probability is determined according to the obtained Q value, the size of the contention window or probability of the contention window size relatively to the total slot can be determined. And contention size and probability and the priority classification is V. Probability contention windows probabilities and the priority has the Q, determine Q. R-QAML max overview is the figure shows the R-QAML max protocol operation. The input data is stored the priority Q according to the calculated value of V. Previous page I showed that. R-QAML max classifies the incoming data packet and store the packet into priority queue according to calculated value V. normal data and event data, and are classified, and after then priority queue stored. And data has two event data, mostly event data and normal data. Event-driven data is usually critical and urgent for transmission. What is event-driven data? Also called priority data, invasion, fire, important breakdown. These data packets are usually called event-driven data in communication. Normal data is an usual measured value and regular measurement. There are many opinions on how to detect event data packet, but in this paper, an abnormal change in the rate with the length of transmission weight Q decrease, transmission Q data, and the weight decrease the Q transmission on abnormal change in the rate which the length of transmission weight Q decrease, and if a sudden change in the measured value is detected, it is recognized that an event is occurred. So classified event-driven data. And next transmission architecture is shown in the figure. Based on Q value calculated for transmission, on inference frame, transmission slot is configured. If the value of Q is high, a large portion of a slot is configured as a high data transmission slot. If the value of Q is low, it is regarded as low or normal data and slots are allocated. High priority data packet is given a small contention window value to enable high priority transmission, and relatively low priority data is given a large contention window size value to partially restrict transmission participation. And data phase has a high and normal or low, and this data phase has a high packet is a large portion, and low or normal data portion is small. And the sync and transmission frame has a sync schedule data phase, and data phase has a high data phase or low data phase has a mixed, and slot configuration has a priority, low, normal priority, high priority has a configure. Contention window adjust has the figure example of a contention window adjustment according to priority. If the priority is high, the length of contention window is reduced so that it can participate in transmission quickly. Contention window is wait time. It can be seen the lower the priority, the longer contention window length, and the shorter. Yes. Contention window adjust the priority. Energy saving layered slot figure. The lifetime of a sensor node can be maintained by controlling the listen period by using the simple communication function of the sensor. Node 1, Node 2 has a communication. Therefore, operating the active section by layer hierarchically reduce transmission loss. The lifetime of the sensor node can be maintained by controlling the listen period by using the simple communication function of the sensor node. Node 1 and Node 2 communicate with each other. Therefore, operating the action section by layer hierarchically and active section, and layered hierarchically. It reduces transmission loss and lengthens the lifetime of the entire network through energy saving of the sensor node. It can contribute to extension. The figure shows the comparison of the delay of the R-QAML MAC protocol proposed in this paper with the related MAC protocols. It can be shown that average delay is row of data with priority. The SMAC protocol basically does not support priority, so it indicates average delay of all transmitted data. SMAC and RMAC, SMAC, RMAC, and RMAC is average delay is a little bit short. And then conclusions. R-QAML MAC protocol was designed to provide using reinforcement learning, differentiated data transmission for higher priority data packet, energy saving of each sensor node. Further study its effects on each parameters using other AI technique and apply. So that concludes my presentation. Thank you.